So this is the stack concept view, and this is the interface, the implementation of this interface, right? The design of this interface included the common functions we care about. Most important for the stack, which is the old operation, happen on the top. When we talk about all the update-based operation, right, which should happen on the top. And then, so after that, it is based on this stack concept view, and we could have the implementation. Let's take a look at the class diagram. And the class diagram, as what we discussed before. So this is stack ADT, and this is the connection ADT. And for the class diagram, is UML class diagram consists of different boxes. Each box corresponding to the class design. And each box usually includes three rectangles, right? This is interface, since interface, which doesn't include the data members. So this reason they only have two rectangles, but regularly for the classes, we have three rectangles. First one, class name. Second one is data member. The third one, function members. And the different this box and has been connected with arrows used to represent a different relationship. And if it's a solid arrow, which corresponds to extends. So the interface stack ADT extends from connection ADT. If this is the dashed arrow, corresponding to implementation. And especially which has the one specific solid triangle in one end. So this is corresponding to implementation. Another one, which is corresponding to composition. And then also, we see it in the class-class relationship, we talk about inheritance, we talk about implementation, we talk about composition, right? So this is three most important and popular relationship. And based on this class diagram, you can see the design. So we see the interface, we cannot use interface to make a specific object. We have to use a specific class, right? So array stack implement the stack through arrays as the building block, and have linked stack. And the linked stack, the another way, it is a single linked stack, double linked stack, right? So doesn't matter what it is. Let's take a look. For linked stack, the lab we care about is linked stack. For the linked stack, we strongly recommend you to use the sketchbook when we ask you for, take a look, the insertion and removing pop and pop, push and pop, or ask you to implement push and pop. We strongly recommend you to use the sketchbook. For example, I just give you example, and then we'll go to the lab question very soon. So, for example, draw a linked stack in your sketchbook, connect this diagram in the sketchbook, show the three items in the stack. So in that case, you see if this is the top, if the top draw on the right side. So in that case, you draw each box, and each box corresponding to linked node, consist data as element, and also next reference used to represent the relationship between the different node. And so this is for linked stack implementation, right? So this is consistent units. And also this is the top, we see it just as linked list. And we use reference to connect all the related elements. But we only in the linked list, in this linked structure, we just need to remember the top. If the operation only happen in the top. If the operation could happen in the both sides or the middle, in that case, double linked list could be more efficient, right? So you need to have two ends, reference to the two ends. And so since the stack operation only happen on the top, and such that most important it is we can have this, we can keep the reference to the top of the linked list. And through the top, this reference, we can find elements in the early elements in the list, right? So for example, this is supposed to connect in this way, right? And this next connect this way. Take a look. When I draw that, I never go through here, right? Because this is the whole load. This is the whole object. I use this one connect with the next related load, right? So this is the linked load. This box is linked load. And we use the reference linked all the related loads, make linked list. This is use linked list to implement stack. And the structure, the building block structure is similar. But just as this stack interface tell us, we only have this guy, right? And we can only push on the top. The operation only happen here. If you need to insert, only insert here. If you need a pop, only pop here, right? So operation cannot happen later this one. This is based on the stack interface, which gave the constraint, right? So that is constraint limited on this operation in this way. This is also the specificity of the stack. Okay, so then of course in this way, in this one, you may need to also connect this should be 7, right? This should be 7, this should be 8, 3, and this should be 12. Hold on. So it's opposite way, right? Because the 12 is the last member added to stack. So this should be 12, this should be 83, this should be 7, right? And this count should be 3. Okay, so you use the sketchbook and to make sure the thinking is very clear. And for all these concepts in this view, we do the same way. Okay, so when we talk about the the pop operation, since with the pop operation corresponding to this guy should be removed, right? If they do have this guy, right? And so in that case, for the pop operation, we care about the different cases. One, that is empty stack, right? If it's empty stack, you pop something, make no sense, right? So have nothing you can pop out, you can remove. So it means if that is the case 1, right? Case 1, if that is empty stack, empty. This is the case 1. So in that case, we will ask throw the exceptions. And the case 2 corresponding to if the stack only hold for one element. So in that case, when you remove this one, your top should be signed to be 0, right? So it is only have one node, one element in the stack. So usually we separate different special cases, and they will handle it or conquer it one by one. And then later you may find out some statements, maybe it's shared among the different cases. Then you can refine your code. But the most important it is we need to make sure what we wrote, what we think is quite clear. We cover everything, right? Every cases, every possibility. So so this is a modern one element in the stack, right? In the stack. In this sketchbook snapshot, what we draw it is it includes 3 elements and the top linked to here. And so in that case, we need to have this pop move to here. And we also, this pop should be signed to be here, right? And also we need to retrieve this element. We need to retrieve. So corresponding to, so now we see here, this one, you can leave the garbage connection to do that, because once this guy has nobody use it, it can be released by the Java or C++ garbage connection or the object-oriented programming that provide that. And such that this one you can leave to the garbage connection, but all the other loads, if they linked with this, should be removed loads, to be removed loads, then you need to change, right? This guy linked with that, then since it's going to remove, you need to change this guy, right? To change this guy, you need a sign to be here. But you also need to retrieve this guy. So the question is retrieve this guy, you need to go from the top to retrieve that. Because in the linked structure, we just need to save what is the beginning. What is that specific head? And through that, we can find all the another one. We only know the top in this case. So such that we need to, from the top, find this object, the data object. Now the question is, do you want to change this one first, or you want to retrieve this one first? We say we should change this one. No, we should not change this one, right? If we change this one first, then in that case, this will be assigned to the top's next, right? Get next. Then this one get lost, because next time from the top, you cannot retrieve this guy. You lost it, and then you cannot return this guy, right? So this is not a good idea to change this top first. In that case, we need to change we need to retrieve this one first. Retrieve this load, retrieve the data object held in this load. Then after that, we change this reference, right, as this tail. And after that, this is a common operation. Every time when you remove, we need to change the count. Different implementation, they may use different variable name. So in that case, you take a look at the code you have. You can give the specific count variable name. That is not the specific the big issue. The most important is why we use the count. The reason is we do not want to, if the people use the size method, we do not want to walk through linked structure and count each element, each load. So this reason we just every time we remove and insert, we give this count. In the most case, here is corresponding to the remove and insertion. At least it happened less than you just say in the case the size this function has been frequently involved. So this is invoked. So this is also the truth. Okay. So after that, this is the then snapshot of that. After you have this 1, 2, 3, these steps, this we're supposed to see, right? And then such that this is for regular case, and such that we assign the top element to the temp, and assign the top next to the top, and the decrement count return the temp. So this is pseudocode, this is steps. And for us, we need to translate this one to be Java code. And how can we translate this one to be Java code? We cannot use this one, right? In the Java, we use a translator here, right? So we use what? Let's say you already define a temp, right? Temp, that is the T. This is let's use it to save the space. I use this one. So this is from the top, get top. Top is reference, refer to the whole load, whole object load, right? Hold this load object, and so which included the data member to data member. Data member for the object-oriented programming, we hide the data because we want to make sure the engineer who implement this class, who can control how to change the data, how to retrieve the data. We only give the method prototype to the student, to the another engineer who need to use our code, right? The team, project team member for the future, right? Or the another people who want to use your contribution. So this is to get the element. This is what we need to write the function. And based on the experience from the previous semester, and some students get it very well here in this pseudocode, when we ask them to write in the exam, we ask them to implement this one. And many students just use the pseudocode. And in that case, you may lose some partial credits. You cannot get total credits because we ask you need to demonstrate your very good programming skills, okay, and also complete understand all this linked structure. This is very important. And then so the second one corresponding to assign top the next to the pop. This one corresponding to take a look at this one in the pseudocode. In the pseudocode, all these kind of things corresponding to get. This is data member. And this is retrieve this data member. In that case, with get next, get element. And when we say assign something to something, which corresponding to, if this is the object, right? Is this the specific object, and which not involved with the container object? Linked load is container object, right? So, okay, so that if that is assigned to be the containers, specific object, sub object, you may need to use a set method. If it is just assigned to some object, you can use just the equals, the assignment statement. Okay, I'm going to continue that. So this will be top assigned to be top get next. Okay, this is related to our NAP question. And then so our third one is decrease. Decrease is easy, right? So it's count minus minus. And the fourth one is return. Okay, so since this is the straightforward, I just leave this one here. This is for regular case, right? Which corresponding to larger than one element. And then so you need to handle with if you only have one element. So in this case, since we do not have a last reference, and such that these two, you can treat them together because we do not have last element, right? That if we have a last reference, and when we say that if there is only one element here, so in that case, we need to change this one to be here. And then we separate these two, we distinguish these two. In this case, if you only have one element, this case you can treat it just like that, because the get the next is equal to long, right? Because that is the end of the list. So this could be long. So in that case, you can treat them together. This is only when we have not a double linked list implementation. It's a single linked list implementation. We only use the top, right? We do not have last because this stack, the operation only happen in one end, only on the top. Okay, so this is for pop operation, and in compared to linked list, relatively easy. And then also check for the push. Check for the push, right? So for the push, and we see here, so the top point to the beginning of linked list. Doesn't matter this is empty or do have a specific element here. Most important it is you need to change this guy. And also you need to connect what you have the new guy with existing top, right? So this is what we need to have the operation. Corresponding to this one, signed to be this guy, only have two reference we need to change. And for this two reference, so we consider the order of these two reference change, right? If you change this one first, then in that case, you change this one second. If you change this one first, what could be problem? If you change this one first, right? If you change this one first, then in that case, this link is gone, right? And at that time, this is not ready, right? This is not ready. If you put this one in the first order, then in that case, now you need to sign this new guy, connect this new guy with existing top. Since the top has been changed, you cannot find the beginning of the original top, because the whole thing here is totally gone. This is gone. It's assigned to be here. In that case, all what you have existing linked structure got lost. So in this push operation, the order is also important. So in the order of changing the reference is very important. So we have to assign this one first and assign this one second, and then we change the count, right? So this is corresponding to what we have here. Listen to that. Today we will have the breakout session. And so this is we explain each operation. Later we ask to implement that. And such that, so this is what we talk about. Okay, so this is, since this one, they make a new node, put the first statement, put as the first statement, so they add one more, right? So, but that is fine. The order of this one, it is, you need to sign this one before you change this reference, right? Before do that. Okay, so this is the pseudocode, create a new linear node, called the temp. So in that case, what we need to do it is, for example, right? So let me write it down here. And the first step, you need to create a new node. And let's name us the temp. And so this is a singly linked load. And you need to specify, this is the generic class. So we need to specify the data type parameter. So we have a temp and assigned to be new singly linked load. And for this one, we can just give this is the first statement. Can you see that? So this is used annotation. After that, right here, I cannot move that. So now I'm going to tap the second, translate second statement to here. Second statement corresponding to, we need to connect this new load with the existing previous top, right? So when we say, take a look here, assign the template next, this corresponding to we retrieve the next reference because this is a smaller container. The whole thing here is a bigger container, right? This bigger container has been, referred by the top, has been, status has been recorded by count, right? This is two data member used to represent the status of this bigger container. And inside of this one have some smaller container. This smaller container stay in the memory in the different locations. Then it's not required then to be the, all this one stay in the adjacent location. They just distribute in the memory. Once they find the location, they put it there, right? Each smaller container. And in the inside of each container, these two data member should be in adjacent location. But each loads, this smaller container, these two should be adjacent, stay adjacent memory location. But what we have this three smaller container, they stay different cities, for example, right? If this is the USA, this is the Charlotte, this is Washington, this is Hawaii, right? For example. And they use reference to link the, to find the next guy, next city, just like that. And then, so for the whole big connection, you just need to get one. This is the agency. You can treat this top as agency, right? Because this agency, making sure the operation happen only on the top. Because we implement the push, we implement pop and peak, right? And so all the other engineering, once they operate on this stack, they cannot control to insert in the middle. Okay, and then so once we know these operations, then so translate this one, you need to be sure this is to get next, assign to the top, and then this is the whole object, right? If we send it to top, so this one is previous, so in that case, it is, in that case, it is you need to change the reference of the data member. In that case, it is you need to use a set method, right? If that it is true. I just want to say, I found out some students confused about assigned to be the object, assigned to object's previous reference. That is different, right? Assigned to previous reference, you have to use set previous, right? For example, this is just reminding me your assignment 2. Please try to work on assignment 2 as early as possible. And you still have 10 days, right? But all this linked structure, they take time to think very clearly. Only when you practice it makes sense. And then now you have time, we have TA, have office hours. You can also reach to my office hours. You have time to do that. And don't wait to the last 2 days. At that time, they will be very crowded in the TA office hours or in my office hours. So in that case, you may not get the spot. You may have to wait. It actually, it take more time. Okay, so this one is assigned the top to be the top, assigned to be what? The new loads. You get something wrong, right? So let me take a look here. Assign, that's good. It's good, no. It's a good example. Assign temp next to top. So this is the reference. This is this is this guy, right? This is this guy. This corresponding to temp is the smaller container. The next is the reference. You want to change this next. We said when we want to change this next, only way we can do it is through this smaller container, right? So this is TMT and set next to be top. And many students they confused about. Let's see if I can change this one. Okay, I'm going to change this one. It's too small, right? I just want to make sure you can see this one clearly. Okay, good. Okay, this is the last. This is the last. Okay, so this is for the this is different, right? It should be here. Okay, so this is the second one. Second one is to sign the temp set next and to be top, right? So no, just be aware of that. So when we say sign the temp next to top, which corresponding to change the next reference to be the top, right? So this is what we do here. This is what the image show you. So this should be this guy, right? This guy. Let's use a different color. This guy, right? So this is what we have to set next. This is corresponding to this pseudocode statement. When you work on your assignment 2, this is what we give you the pseudocode, right? So, or maybe in the code, or maybe in the description, but don't be confused about that. This is we want to sign the sum next to the top because this is a data member of this smaller container. The only way we can reach to this this object, this small variable, it is use the set method. We give this as a parameter and give this one to the next. This is this statement tell you, okay? So, okay, I'm going to move the next one. And the next one, it is to assign the top. So which is assigned the top to be temp. And then the first step, which is the same, right? With the first step, it is the increase the count. Okay, so this is the stack operation. Okay, very good. And then so we see in this module, and we also ask everybody could practice and compare, evaluate the different implementation. So this we put in this slide. You can use that. So this is, we see this is for array-based implementation. You use array, and here this top uses represent the next available guy, right? So this top is corresponding to the index for next available guy, 3, right? So this top for the array-based implementation, they has 2 rows. First row corresponding to, they can use it for calculate how many total elements included in this stack. Because the last element, the element which stayed in the stack the longest time, that guy is on the bottom. And the bottom, which is the index of bottom for the stack, which is 0, right? So such that you can use the top to represent how many elements in the stack. And also this is the first row of top. Second row, it is uses top to represent, well, is available space. What is this index? What is position for next guy, right? For next guy. So this is for the array-based implementation. For array-based implementation, for this lab, we already gave the code, but in your site, you need to make sure you can also implement that even without the hint, for example, right? And then so this is different from linked implementation. And for linked implementation, if in this case, if you have 3, this top already, but depending on which one you put as the end, right? If you see this top here, then in that case, then the next point here, right? And this one point here. This guy is this guy, which stay in the end of this guy stayed in the stack for the longest time. Or just say this is the earliest one who entered into this stack, not get removed, right? Okay, so this is different. This is array-based implementation, and this is the linked-based implementation, right? So so for array-based implementation, you also need to know how can we implement it for push, how can we implement it for pop, right? So in that case, for the array-based implementation, in your side, maybe you feel very easy, right? For example, you add a new one here, and then so you signed this array, get the array element, and then assign this one to here, and change this guy, right? Only have these 2. If we pop out, corresponding to this guy should be removed, and then so this one need to be 3, right? So this is for array-based implementation. For array-based implementation, some of students feel confused, which is in the, let me show you. Some students feel confused, which is in the constructor. So array, since the stack, it is generic stack, and such that this T is the data type parameter. And when we initialize the stack, we need to first initialize as the object and the static to be T array. Okay, so this is only the one thing. And for the linked stack, this should be assigned to be long. Okay, and then for the push and pop, and so since this is for the array-based implementation, it's quite obvious. And only thing it is, consider for array, consider what is the upper bound of this array for the container capacity, right? If the elements, all the elements, all the space in this stack has been occupied, so corresponding to reach to the capacity, so you may consider to expand it, expand the container, right? Or else you just say limited on that default capacity. Okay, so this is for the stack implementation, and actually we cover this all. Now it's your turn to implement for that. Just try as what we discussed. So I would like everybody. So now we have 15 minutes. In this 15 minutes, please download this one, and then I will ask ask you, everybody, please go to the link from this lab, download this one. After you download this one and zip it. Once you unzip it, and then you can put in the NetBeans. You can put in the NetBeans in the way open project or import project. Either way, okay? And then so let's just say after that it is this is for Gen unit test, and for that case corresponding to, before you implement that, you check for each function what you need to verify. What is suspicion? This is some very straightforward. For the push, you may think about if it's empty, if you push, what happened, and the element can be stay in the correct position, right, or not. And on the pop, or the same thing. And they check the size has been changed or not. And element, the previous element, the element next to the top has been the new top or not. And the previous element staying there or not. All this unit test, it is what you would like to verify this function of each method has been, the goal of this function has been reached or not reached. And the status of the linked stack has been maintained through the different method or not. So that is the main idea. And then the only thing it is we say that once every time when you work on a specific, for example, pop method, right? So since the pop method they do have one specific case which could throw exception. So in that case, you may need a separate testing method that will make your code clean, right? So I think this is quite clear situation. So I would like everybody, let's just say we have a, okay. So now I would like to assign each student in the group. Every student, since the test for this task, part 1 is just ask you to install the this start code, right? And launch it in the NetBeans and think about the test method. And this test method we already provided, except I think it's peak we didn't provided that. So I want to ask you working in the team to check for this test peak method. So I want to check, let's say we just give you 7 minutes, right? 7 minutes. And then, so if you could finish, you finish. If you could not finish, we will get together on Monday, we finish the part 2. Okay, so I'm going to send you in the breakout session, and then David, Andrew, and Tao, and please do me a favor and check for each breakout session. We work together to check each different breakout session. You can check the previous let's just say. Okay, I'm going to open the old rooms. Okay, so for you in your site, and please join the room. So I'm going to the breakout room 2. Let's just say David and Andrew in the different room or not. Let me check. Tao is not here. Seems like that. Okay, so that's good. And David and Andrew in a different room. I'm going to check room by room. Okay, please start. We have 7 minutes. Okay, so I'm going to join the break room 2. Dear my friends, are you in the specific room? Still room 2 or which room it is? Could you tell me which room? Thomas?
Hmm?
Which room you stay?
I was in room 1.
Oh, room 1. I see. So I
Yeah.
accidentally go to the. No, that's good. I also want to check with you. So we have I think almost there. We have 1 more minute. I want to check with you. So do you think in this lab, at least this part, is clear for you or not?
It's relatively clear, yeah.
Okay, so if you say clear, I will feel much better. You say roughly clear. So what do you mean roughly?
Hold on. Let me take a better detailed look at it.
Yeah. Did you have time to take a look before you go to class? Maybe not
No,
yet. Right?
not yet. I haven't worked on it yet.
Okay, good. That's don't worry. Yeah. So did you already put in the NetBeans?
Yes, I did.
Okay. Did you started to take a look at the test method?
No, I've not.
You're not yet, right?
No.
I see. Maybe you spend the time on reading the lab questions, right?
Yeah, no,
I
I
see.
will.
I see. So next time I was make sure before I will ask a student to read that before go to class.
Yeah.
Because, the time is quite the schedule is tight, right?
Yeah, yeah.
Okay. Yeah, that's fine. So then so for the test, I think maybe we need to get it together because our time almost there. Okay.
Mm,
So let's get it together just to summarize and then so get a release. Okay.
yeah.
Okay.
Okay.
I'm going to let's all. Let's send a message to everyone, and then so we needed to join the main session.
Yeah.
Okay, then so I'm going to end this session, end the breakout session. Okay, I'm going to end. Okay.